Okay, question 2, part A, we've got sine squared theta plus cos squared theta equals 1, and we're trying to show that 1 plus cot squared theta equals cosec squared theta. Well, this time if we divide through by sine squared theta, sine squared divided by sine squared is 1, cos divided by sine is 1 over tan, or cot, so cos squared theta divided by sine squared theta is cot squared theta. And 1 divided by sine squared theta is cosec squared theta. And just check the format, and 1 plus cot squared theta equals cosec squared theta. That's exactly what we're looking for, so done. Okay, part B, here we've got an equation 2 cot squared theta minus 9 cosec theta equals 3. So in these equations where you've got a quadratic element but also a linear sort of element, in terms of the cosec theta is not squared. It's the non-quadratic elements, so the cosec theta here, that we want to retain, because we can't change that very easily, whereas we can change the cot squared theta quite easily using the identity we generated earlier. Okay, so if we rearrange that to make cot squared the subject, we can see that cot squared theta is always equivalent to cosec squared theta minus 1. Okay, so we can now substitute the cosec squared theta minus 1 in to this equation here in place of cot squared. So doing that then, okay, we get that, and we're going to then expand it. We've got a quadratic element, so a squared term, a non-squared term, and then numbers, so it's going to be a quadratic format at the end of the day. So expand the brackets and tidy up into the quadratic format. Bring the 3 across, end up with a minus 5. Okay, and so then we're going to try and factorize that. So 2 cosec theta at the front there, cosec theta at the back there. We want to get the two numbers to multiply to give 5, and we're going to be trying to create a minus 9 in the middle there. So the two numbers need to multiply to give minus 5. So if we make that minus 5 there, that's then going to multiply there to give minus 10 cosec theta. Make that a plus 1, that's going to be a plus 1 cosec theta. So minus 10 cosec theta plus 1 cosec theta would add to a minus 9 cosec theta. 1 times minus 5 is minus 5. So we're done. So now let's solve, or start to think about what the brackets are. So 2 cosec plus 1 equals 0. So cosec theta itself is minus a half. And then over here cosec theta is going to equal 5. Okay, so there's no such inverse cosec button on the calculator, so we need to rewrite this in terms of sine, cos or tan. So cosec is defined to be 1 over sine theta. Okay, and then we're ready to take the reciprocal of each of those to make sine theta the subject then. So sine theta equals minus 2 over 1, or just minus 2. And over here sine theta is going to be 1/5. Now sine theta equals minus 2, that'll have no solution because minus 2 is less than minus 1. So there'll be no solution there. Check it on your calculator by all means, but you'll find it's a math error. Over here then, so inverse sine of 1/5. Check that on your calculator. Inverse sine of 1/5. Coming out with 11.537, etc. Well, 11.536, etc. Okay, but then we're going to need to generate the alternative angles. So to do that, for a quick sketch of the sine curve, or you can use your cast diagram if that's the method that you use. Okay, so 11.53, really quite close here, so 11.5, up, along, down, that angle there, well that's going to be 180 minus 11.5, 36, etc. Okay, so I've still got that on my calculator, so 180 minus the answer, 168.463, etc. Okay, and therefore, given the answers to one decimal place, theta equals 11.5 or 168.5.